As always, it's so exciting at DLD to bring the fields together. And of course, the question, what do we add? What does each of us add? Is one question. The question is, of course, what can we add together? And always believing in this idea that 1 + 1 can be 11. We are so excited to welcome here Eduardo and Marcus. I also wanted to thank, of course...
Sorry to interrupt you, but you have to go closer.
All right.
And before we start, we should really give another big round of applause to Steffi Czerny for bringing us all together. And I wanted to also thank very deeply Hubert Burda, because I met actually Hubert Burda when I was still a student, and at that moment I was really only into art. And Hubert, from a very Renaissance idea, said you should think broader and look into science. So I'm very, very grateful to Hubert, and I think we should give Hubert a very big round of applause. Now, trying always to bring art and science together, a couple of years ago I sent an email to Eduardo and to Marcus saying, it's urgent, because it had to do with the fact that we spoke with Eduardo in Mexico City, and actually I found notes from our first conversation where, Eduardo, you told me about these patterns that connect, about geometry, but you also talked about it having a social and political dimension. The amazing work, of course, Eduardo did for the '68 Olympics, by not only being so deeply involved with all the graphics, but really carry visual arts into the city, the tickets, the seats, the roads. It was really a form of artistic urbanism into society. And we talked about what Steffi calls this pattern that connect. And at the very moment you told me about that, I was reading Marcus's work about patterns in mathematics. And as often with these introductions, and I think one should do this every day. We should all do it every day. When we wake up in the morning, we should connect someone we know to someone else we know and bring them together. It's almost like a daily ritual. And what happened then, little could we know that actually an amazing dialogue unfolded. And Marcus and Eduardo have met since then twice, actually, in Mexico, and are going to tell us today about what they're exchanging, about art and science. Of course, as Steffi already said, Marcus is so instrumental in bringing science into society, as Eduardo brings art into society. Marcus is the public face of science in the UK, and is also, every year, the science advisor to our Serpentine marathons, the knowledge festivals where we bring all the disciplines together. Please give a very, very warm welcome to Eduardo Terrazas and Marcus du Sautoy.
Thank
you. And my first question is actually Steffi's question. What do you add and what do you add together?
Well, as a mathematician, of course, I add all day, but no, actually I don't. I do very little arithmetic, and actually I think a lot of people have a misconception about my subject, that it's about arithmetic, and actually it's exactly what Steffi said. If I was going to define a mathematician, it's a pattern searcher, and I think Steffi's right that we're all looking for patterns, and we have different languages that we use to explore those patterns. So for me, I think one of the exciting things that I've experienced coming to the Serpentine, being connected with artists, is finding that very often we're interested in very similar structures, but we have very different languages to navigate those structures. And by bringing those different languages together, it allows us to see new things. So I hope that bringing my mathematical perspective on the world maybe provides a new way to explore something that an artist is interested in. But conversely, I think very often an artist will bring, for me, a new way of seeing and ask new questions that I haven't thought about. We talked earlier about the bubbles that we all are stuck in, and the science-art bubble. Those two bubbles have been kept apart by our education system. And science, I am an ambassador for science as the professor for the public understanding of science in Oxford. And we need to find ways to communicate. And I think that the language of art helps us to form a bridge between this, the complex world of science and giving new ways. I mean, I called this session Science plus Art equals New Visions, because each one helps us to see our complex world in different ways.
Well, my point of view is that we need not only science and art together, but we need a lot of the other areas of study, economics. I was very good friend of a great economist in Mexico, and we worked together in a thing for the Club of Rome. And the more and more I go through the world, the more and more I think we need to be together and interchange. People are very much in their own little world, thinking that's it. And that's not it only. It's this and that and that and that and that. This picture that they're putting in is different ways of looking. So this is a painting, and that's a real city. And this is a painting I did. And that's a stone. And that's a road, and that's a road also in the painting. So you can find a lot of things together if you really think about the world as one world. So when we got together, Marcus and I made a trip to Teotihuacan, the Mexican pyramids, 4th centuries BC. And we had the most marvelous conversations of things that we saw, of things that have been made 4,000 BC in Mexico. And we discovered a new way of looking at the stars at that little place. They had a little pond, and they had a kind of a patio, and they put mica on the floor, and that was their observatory of the stars. And all the pyramids were oriented according to the stars. The pyramids at that time were oriented to the stars. So we need to find that the world is one whole world, that we need to, we're in a crisis of not looking more. We're really in a crisis. I like to say very poetically, in the crisis of beauty, because beauty shows you the truth. And we're in a crisis of looking for things of beauty which shows you the truth of the world.
I think this word beauty for me, yes. This word beauty for me was one that I think brought us very much together, because beauty is a quality that makes the best mathematics and leads you to the truth in mathematics. I mean, and it's sort of an embarrassing word almost in the art world, I think now, using that word beauty. But actually, for me, and I think for Eduardo, it's been an important guiding motif. I mean, it's extraordinary how the universe is based on beautiful pieces of mathematics. It's not messy. Even biology has its origins in very simple laws which create extraordinary complexity. And I think that's, there's a kind of, we do live in a complex world, but the stunning thing is, at its basis, is something quite simple and beautiful. And that was actually the first time we met. I'd just given a lecture on infinity, I think, in Mexico, and Eduardo and I sat down, and Eduardo showed me this diagram that is at the heart of all of these images that you're seeing on the left. And this diagram he calls the cosmos, and it immediately resonated for me as distilling the essence of a way to see the world. And I think, for me, that's what mathematics almost is. It's about throwing away the unnecessary and seeing. I think I can even, let me see if I can pull you up the diagram. And the diagram for Eduardo is, here we go.
That's it.
Actually is a diagram of the universe. You don't necessarily need to know that, but here's the diagram. Do you want to explain the components, or shall I? So, if you want a universe, you need a stage on which to act out your universe. So this is the X, Y components, the horizontal and diagonal line. We live in a 3-dimensional, or if superstring theory, maybe 11-dimensional, but diagrams are good at saying, oh, just 2 dimensions will be enough. And then we have where we live, the planet Earth. That's the circle in the center. And then we have the universe that we can see. In fact, the ancient Greeks always said that we lived in a kind of celestial sphere. Einstein actually shows us that we genuinely do live in a bubble beyond which we cannot see the universe that's out there because there hasn't been enough time since the Big Bang for the light to arrive to us. So in fact, we are in our own little bubble and we do not know what's beyond there. And even more frightening, the accelerated expansion of the universe is pushing things over this cosmic horizon faster than it's expanding. We're actually losing knowledge about our universe. So that larger circle represents what we can see of our universe. And then the fundamental forces we discovered at the moment, 4 fundamental forces, gravity. Newton had the insight about the big and the small being connected by gravity, electromagnetism, the strong nuclear force and the weak nuclear force. So these are the square inside. And then the interesting challenge, infinity, that was the talk I was giving when we first met. Is our universe infinite or not? We'll never be able to see it if it's infinite. It might be one of the unanswerable questions of the universe. So I love the fact that Eduardo put these 2 diagonal lines, which are almost asking the question, how far does this thing go? Or does it wrap back round again? We live in a finite universe wrapped around in 4 dimensions. So for me, when I saw this as the kind of structure around which Eduardo has been designing all of these beautiful images for 30, 40 years, and yet at its heart is a diagram that explains our current way that physics sees the universe, it immediately resonated as something that
it's
connected
fascinating
us.
to hear your reading of Eduardo's diagram. And Eduardo, of course, is at the base of your series Cosmos. And you explained that to me in Mexico. And indeed, actually, at the base of most of your work, of your architecture, your graphic design, your painting, is always a diagram. You said one of the powers of a diagram is to throw away unnecessary information. And so it's possible that the 2D image is enough to capture the structure of our universe. So in this diagram we are looking at, you sort of define also rules of the game. So after Marcus's reading, it would be great now to have your reading of your diagram.
Well, my reading of the diagram, I've done now 379 images of this diagram transported into what I consider my impression of trying to play with it.
A prime number, very glad to see that. 379.
379 is a prime number. But I play with the elements of the diagram. I play with parallels, with different tones, and trying to create what I consider are dimensions and images that we can see in the universe, in the cosmos.
But it was interesting, I did a program for the BBC about diagrams, some of the most important diagrams of our time, the diagram of DNA that Crick and Watson published in the paper Nature. That was actually drawn by Crick's wife, Odile Crick, who is an artist. The original diagram that I saw in the Wellcome Trust Library that Crick drew is awful. It's terrible. You can't see what the essence of this idea of the double helix is. And it took Odile to crystallize and realize that diagram, which is the one that's in Nature. So there was very important, the combination of the artist and scientist to communicate this extraordinary understanding of how life evolved.
And it's try to understand it with a simple diagram. I think everybody right now is trying to see the world very complicated, and they paint and they say, that's the world. And simplicity is the glory of expression.
Now, one more thing before we move on in other topics related to the diagram is, Marcus, the diagram, as you said, is an important feature in math and sciences, but even in humanities, if you think, actually, I reread Michel Foucault the other day, where he talks about the diagram of power, a map of relations between forces, within a social system. So I wonder if you, as a mathematician, have any thoughts on this idea of the diagram as a tool for understanding kind of the world.
Yes,
and its social dimension.
Absolutely. I think one of the things that we find very difficult to understand as human beings is exponential growth, the power of things to explode. Here's an interesting challenge for you. A vampire has to feed off a human, but once they bite the vampire bites the human becomes a vampire and also needs to feed off another human. So that means that, say, every month they need to feed, so how long will it take for the whole of the planet to become vampires? Because it's doubling each month. So is it 33 weeks, 33 months, or 33 years? So, well, let's take a vote. How many people think it's 33 weeks will take to... okay, you're all... yes, I've perhaps prepped you. How many think it's 33 months for the whole planet to become vampires? How many people think it's 33 years? It'll take at least that for... And most of you haven't got a clue. Okay, right. It takes actually only 33 months for exponential growth to cover the whole planet in vampires, which is probably a proof that there are no vampires, unless we're all vampires. But I think exponential growth is at the heart of the crisis of the effect of things like climate change on us. And to understand quite what this means, I think is socially very important. So when Eduardo showed me this diagram, which is the use of his diagram to explore the power of exponential growth to wipe us out, I thought this was absolutely where the artist and scientist and the politician can come together to use our different languages to try and communicate important images, or important ideas, which are sometimes hard for us as humans to navigate.
It's interesting that because that brings us also to economy. And, I studied with Binswanger, the economist who early on, in the 70s already, 80s, wrote this extraordinary book about, limits of growth and how we need to factor ecology into the economy. And of course, Eduardo, that's what fascinated me so much when we met, is your connection to economy. And you told me, actually in Basel in 2013, that one of the problems of this current world is that everything is growing exponentially. Following up on what Marcus said, speed, antibiotics, the power of explosions, the human population is growing exponentially. You explained to me that as an alternative to this exponential growth, you opted to use organic growth to create the variation of your Cosmos series. You said I'm saying things with geometry. Can you explain that to us more? Because it seems very relevant for the world right now.
This painting, I consider a painting, has 16 panels, originally all in white. 16 panels. And the first panel is white. The second panel has a line on the middle. The third panel has a line in the middle and a line crossing the middle. And on and on and on. It begins to grow exponentially. And at the 16th panel, the panel goes black. So that's exponential growth. It goes doubles until it goes to a new, obliterate the white and the black comes. But after the black, is there more blacks? Sure, there's more blacks. And there's more white on the left-hand side of the white. So by a simple painting or diagram, you can find the exponential growth, and that's what's happening to the planet Earth. It's growing exponentially. The growth of the exponential pattern that the world has right now is perhaps going to kill us all of us too, if we don't do something, because it's going to continue growing like that. And the speed is more, and the growth of the CO2 and the air is growing, and everything is growing more and more and more.
But I like Marshall McLuhan's statement, which you often quote, Hans Ulrich, that, that art is our distant early warning system. And I think that's the role, it's not just good enough to go to galleries on a Sunday afternoon. This is a very urgent language to help us to understand what is going on. And I think the collaboration between the artists and the scientists helps us to articulate from our side more clearly the crisis that we might be in.
Now, often at the DLD, I ask my favorite question, which is the question about unrealized projects, because I always think, we know a lot about architects' unrealized projects because they publish them all the time, and they often get reality produced, by publishing unrealized projects. But we know nothing, almost nothing about artists and scientists, mathematicians, unrealized projects. And actually, I ask this question every day, but the wonderful thing is that often I ask them at DLD, actually somebody in the audience then helps to make it a reality. It happened several times. The school Strelka was born like this when Rem Koolhaas said here at the very beginning of DLD, he dreamt of an architecture school, and then, the school happened. So I thought it would be urgent to ask you both about unrealized project, a project which has been too big to be realized, or sometimes projects are too small to be realized. Sildo Meireles wanted to put a little cube into a big museum, and it took him a long time to find someone who would just have the little cube and the rest of the museum totally empty. So that project was too small to be realized. Then there are projects which are censored, projects which are utopic and completely unrealizable. And then, as Doris Lessing also once told me, there are the projects we haven't dared yet to do. There's not only censorship, there's sometimes a form of self-censorship. So I was curious if you could both tell us about one of your favorite unrealized projects, or maybe one what you could do together.
Well, I suppose mathematics is a living, breathing subject because of all the unrealized projects. So conjectures, for me, are what get me up in the morning, the things I don't understand. But the greatest one is trying to understand prime numbers. So these prime numbers go on to infinity. One of the great German mathematicians, Bernhard Riemann, understood perhaps a way to navigate these, but it's still a conjecture that we're working on. We don't know how to do it. If there's anyone in the audience who can help me solve the Riemann hypothesis, please come and talk to me after the talk.
With this image that you're seeing here, as I said, I've made 370. And you can...
Too much weight.
So the unrealized project is that this gets printed as a book, right?
Yes, it would be fantastic to print it in a book.
Oh, I thought it was going to be to make infinitely many of them, if there are...
So I see we have 58 seconds, and there's actually one question I wanted to end with, and that's something, Marcus, you said before in the coffee break. Often with conferences, important things happen in the coffee break, as we know. And Steffi always encourages all of us to have as many coffee breaks as possible at the DLD. And you said before in one of these coffee breaks that you think that actually mathematics is very close to art. And I always wondered why, whenever I introduce you to an artist, there is this extraordinary dialogue immediately. It started all when we connected you to Gerhard Richter, and there have been many, connections with artists ever since. So I was kind of wondering if maybe, to wrap it up, you can tell us why you think that mathematics is so close to art.
I think that mathematics has a very different quality to science, which is that we're quite happy to have universes, worlds, which don't describe our physical universe. Once a model doesn't fit our physical universe, the scientist throws it away. I'm still interested in that. So it means that mathematics is a much more highly creative subject, because I can create a world, Harry Potter has wizards in it, that's a fiction. But I can create mathematical worlds which are also fictions and don't describe this world. But very often they give us new ways to see our world, so that's why there's a connection. But I think mathematics is as a highly creative subject, which is why exposure, and science as well, and that's why exposure to artists can only encourage our own creativity to come up with new ideas.
Thank you so much, Eduardo. Thank you so much, Marcus. Thank you all.
Thank you.
Thank you.